Death machines. That's what these infamous motorcycle engines were. Not performance legends, murder weapons. They kicked back and broke legs. They seized mid-curve and launched riders into trees. They dumped oil on rear tires at 100 miles per hour. When engineering ambition outran common sense, riders paid in blood. These weren't just unreliable, they were deadly. Here are the 10 most lethal engines ever bolted into production motorcycles. Number 10. The Royal Enfield Bullet Electra X, the AVL engine. The 346cc single-cylinder AVL engine, powering Royal Enfield's Bullet Electra X, became infamous for its violent personality. Producing 18.5 horsepower at 5,000 RPM and 21 pound-feet of torque at 3,500 RPM, this air-cooled thumper loved punishing its riders. Most notorious was its vicious kickback. The engine could suddenly reverse during starting attempts, slamming the kickstarter into riders' legs with bone-breaking force. Improper decompression technique virtually guaranteed injury. The engine's cooling limitations meant sustained speeds above 65 miles per hour often resulted in seizures, while the undersized oil pump struggled to maintain proper lubrication. Early models utilized an unreliable CDI ignition system prone to timing errors, causing dangerous misfires exactly when you needed power the most. The chassis suffered too. Excessive vibration at 3,200 to 4,000 RPM loosened critical bolts and cracked frames over time. Royal Enfield addressed these issues gradually, but not before the AVL earned its reputation. Despite generating modest power figures, the dangerous combination of unpredictable starting behavior, thermal vulnerabilities, and vibration-induced failures made this seemingly simple engine a legitimate threat to rider safety. From colonial kickbacks to desert adventures. Number 9. The KTM 950 Adventure. KTM's 942cc LC8 V-twin was revolutionary when unleashed in 2003. Cranking out 98 horsepower at 8,000 RPM and 70 pound-feet of torque at 6,500 RPM. This Austrian powerhouse promised off-road dominance, but delivered equal measures of excitement and terror. What made this engine particularly treacherous? First came the hyperactive throttle response. Twist your wrist a millimeter too far and the front wheel launched skyward without warning. Great for showing off, terrible for surviving Saharan sand dunes. Then there's the cooling system. Those twin radiators struggled in slow going, spiking temperatures in minutes when not moving fast enough for adequate airflow. The dual 43mm Keen carburetors required constant synchronization, with altitude changes destroying carefully tuned mixtures. Early models suffered from insufficient oil circulation during extended highway stretches, leading to catastrophic failures precisely when riders were farthest from civilization. Perhaps most alarming was the clutch slave cylinder's habit of suddenly failing, eliminating any clutch control. For a 507-pound machine with 98 wild horses, losing clutch function while navigating technical terrain often meant an express ticket to the emergency room. High-tech nightmares give way to some vintage violence. Number 8. The Vincent Black Shadow. Built from 1948 to 1955, the Vincent Black Shadow's 998cc V-twin remains legendary, both for its phenomenal 55 horsepower output and for its deadly temperament. This hand-built British monster achieved 125 miles per hour when most vehicles struggled to reach half that velocity. Unlike modern superbikes, the Shadow provided this performance without corresponding safety equipment. Those measly 7-inch drum brakes required football field stopping distances, while the frame, innovative for incorporating the engine as a stressed member, flexed alarmingly at speed. The gearbox couldn't handle the engine's torque for long. Riders faced frequent rebuilds, as second-gear teeth sheared without warning. The wet multi-plate clutch overheated during aggressive riding, causing unpredictable slippage exactly when you needed positive engagement. Engineering challenges stemmed from mixing materials. Aluminum cylinders expanded differently than steel crankcases, creating oil leaks and compression issues. The Smith mechanical speedometer wildly underreported speeds, leading riders to travel far faster than intended. Despite being technical marvels, Vincent's metallurgy couldn't match its design ambition. Valve failures occurred routinely, main bearings collapsed, and oil pumps failed. Yet owners considered these regular maintenance rather than design flaws. Such was the price for riding the world's fastest production motorcycle of its era. From British thunder to some American rumble. Number 7. The Harley-Davidson Panhead, from 1948 to 1965. Harley's Panhead, named for those distinctive rocker covers resembling upside-down pans, powered Milwaukee's machines through America's post-war boom. This 1200cc V-twin produced a modest 55 horsepower, but massive 75 pound-feet of torque at just 2,700 RPM. Now, heat was the Panhead's mortal enemy. Those aluminum heads atop iron cylinders created thermal expansion nightmares. Gaskets failed regularly, spraying oil everywhere. Riders joked you hadn't owned a real Panhead unless it marked its territory like a nervous dog. The primitive oil circulation system barely reached the top end, causing premature valve and rocker wear. The 6-volt electrical system proved woefully inadequate, with headlights dimming to mere candles at idle. Starting required perfect technique. Kick too softly and nothing happened. Kick too hard and you risked a broken ankle when it kicked back. Hydraulic lifters, innovated for 1948, required precise oil pressure to function properly. Too hot, which was common in traffic, and they'd fail completely. The 4-speed transmission shifted with all the precision of stirring concrete with a spoon, requiring brute force to find gears. Now, despite these flaws, Panheads delivered unmistakable torque and reliability, if you respected their limitations and maintained them religiously. Now, for many riders, that iconic potato-potato rumble justified the engineering compromises. Survived a killer bike? Hit that like button, subscribe and ring that bell for more automotive content. And don't forget to share this with your mates for some more engagement. Next, to Japanese turbo science. Number 6. The Kawasaki GPZ 750 Turbo. Kawasaki shocked the motorcycle world in 1983 with their GPZ 750 Turbo. This 738cc inline-4 featured the first mass-produced motorcycle turbocharging system, boosting output to 112 horsepower at 9,000 RPM and 70 pound-feet of torque at 6,500 RPM, numbers that terrified insurance companies worldwide. Now, what made this bike dangerous wasn't just its raw power, but how that power arrived. Below 4,000 RPM, the engine felt completely docile. Then the turbo would suddenly spool up, delivering a violent surge that transformed the motorcycle instantly. This unpredictable power delivery often overwhelmed the tubular steel frame, designed for much less torque. The electronic fuel injection, cutting edge for 1983, sometimes miscalculated fuel mixture, running dangerously lean under boost and causing detonation. The turbocharger itself operated at extreme temperatures, cooking the rider's right leg while creating thermal stress throughout the powertrain. Now, worse still, the braking system proved utterly inadequate for a machine capable of 146 miles per hour. Once that turbo kicked in, riders discovered the suspension geometry wasn't engineered for such acceleration, creating alarming wobbles when power hit during cornering. Only 1,500 units were produced worldwide, not from manufacturing limitations, but because riders quickly recognized this technological marvel was trying to kill them with physics-defying acceleration. Next on the list, number 5, the Triumph Trident T160. Now, Triumph's answer to Honda's CB750 arrived in 1975, packing a 741cc 3-cylinder power plant that produced 58 horsepower at 7,250 RPM. The T160 looked fantastic on paper, but concealed numerous mechanical gremlins waiting to surprise unwary riders. The triple's fundamental issue was balance, not vibration balance, but engineering balance. Unlike twins or fours, this 3-cylinder configuration created primary forces that shook everything to pieces. At 4,500 to 5,000 RPM, the entire motorcycle buzzed violently, loosening fasteners and cracking components. The triple AML carburetors required constant synchronization. Now, even factory-fresh bikes rarely had all three properly adjusted. When improperly tuned, cylinders fought each other, creating dangerous surging and hesitation. Oil consumption became a critical concern. Those 3 cylinders burned nearly a quart every 1,000 miles when ridden enthusiastically. The transmission suffered from weak detent springs, causing gears to slip out unexpectedly during acceleration. Now, despite these issues, the Trident delivered an intoxicating exhaust note and reasonable handling when everything worked properly. Unfortunately, achieving that condition required more mechanical sympathy and maintenance skills than most riders possessed. Next, to an Italian exotic. Number 4. The MV Agusta F3 800. The 798cc triple powering MV Agusta's F3 800 represents the modern evolution of dangerous motorcycles, not from poor engineering, but from excess performance. This liquid-cooled DOHC 12-valve engine produces 148 horsepower at 13,000 RPM and 65 pound-feet of torque at 10,600 RPM in a package weighing just 173 kilograms dry. Statistics don't capture what makes this engine treacherous. The counter-rotating crankshaft, spinning opposite to the wheels, reduced gyroscopic effects, making the bike unnervingly quick to change direction. Combined with the aggressive throttle-by-wire system, even experienced riders found themselves surprised by the F3's nervous reactions to small inputs. Early models, from 2013 to 2014, suffered from electrical demons. The sophisticated electronics would occasionally glitch, cutting power mid-corner or delivering unexpected throttle inputs. The ride-by-wire system's multiple maps sometimes switched unexpectedly between modes. Heat management also proved challenging. The compact triple pumped enormous heat toward the rider's legs in traffic, while the tightly packaged exhaust headers ran perilously close to plastic components. The cassette-style transmission required precise shifting technique. Ham-fisted riders found false neutrals with alarming frequency. Now, the F3's engine demanded expertise beyond most riders' abilities. Its blistering acceleration at 0 to 60 miles per hour in 3.1 seconds and peaky power delivery at 10,600 RPM created a machine that punished any mistake with immediate consequences. Moving on to some British engineering. Number 3. The BSA Rocket 3. Emerging in 1968, BSA's 740cc triple produced 58 horsepower at 7,500 RPM. Impressive figures that hid numerous dangerous quirks. Badge engineered alongside the Triumph Trident, the Rocket 3 shared its siblings' mechanical architecture but added distinctive styling and slightly different tuning. Now, what made this engine particularly hazardous was its mounting position. BSA placed the engine higher in the frame than Triumph, raising the center of gravity and creating a top-heavy handling characteristic that became unpredictable at speed. The frame itself, a traditional steel tubular design, flexed noticeably during hard cornering, especially when the engine was working hard. Constant vibration attacked every component. The head-steady bracket regularly cracked, allowing additional engine movement. The pressed steel oil tank developed stress fractures, while electrical connections worked loose with predictable consequences. Triple ML concentric carburetors theoretically delivered precise fueling, but synchronizing them required specialist knowledge and equipment. Even slight imbalances caused flat spots and hesitation during acceleration. Dangerous when overtaking. The engine itself suffered from inadequate crankcase breathing, pressurizing the cases and forcing oil past every gasket and seal. Higher compression pistons introduced in later models subjected the bottom end to forces beyond its design parameters, leading to main bearing failures. Now, despite these flaws, the Rocket 3's distinctive howl and impressive torque delivery made it an object of desire, albeit one that demanded mechanical sympathy. For a runner-up, a two-stroke Fury. Number 2. The Aprilia RS125 with a Rotax engine. Now, don't let its modest 125cc displacement fool you. Aprilia's RS125 packed the deadliest punch-to-weight ratio in the motorcycle world. This liquid-cooled single-cylinder two-stroke screamer produced 34 horsepower at 11,000 RPM and 18 pound-feet of torque at 10,500 RPM in a package weighing just 128 kilograms. So what made this tiny terror so dangerous? Well, first came the power band. Below 7,000 RPM, nothing happened. At 8,000 RPM, power arrived explosively, doubling output within 500 RPM. This radical power delivery caught countless novice riders off guard, especially in wet conditions. The Austrian-built Rotax engine required fanatical maintenance. Two-stroke oil injection systems failed regularly. When they did, piston seizure occurred within minutes. The recommended 100-to-1 premix ratio provided minimal lubrication margin. Slightly too lean, and top-end components welded themselves together catastrophically. Restricted versions, limited to 15 horsepower for licensing regulations, encouraged dangerous modifications. Removing restrictors without corresponding carburetor, ignition, and exhaust changes created engines running dangerously lean, while full power conversions overtaxed standard components not designed for sustained high output. The exhaust power valve, electronically controlled on later models, frequently stuck, causing unpredictable power delivery exactly when consistency was needed most. Cylinder head gaskets failed frequently under high compression, while water pump seals leaked coolant onto rear tires with predictably slippery results. Now, for many teenage riders, these risks seemed worth taking for the intoxicating power-to-weight ratio. On the top of our list, A true Japanese engineering nightmare. Number 1. The Yamaha XS750, the triple engine. Yamaha's ambitious entry into the multi-cylinder touring market arrived in 1976 bearing a 747cc triple, producing 64 horsepower at 7,500 RPM. This liquid-cooled DOHC 6-valve engine, paired with shaft drive, promised Honda-beating reliability, but delivered a mechanical time bomb instead. The XS750's primary design flaw centered on second gear. The transmission used undersized components that couldn't handle the engine's torque, causing second gear to literally jump out of engagement during acceleration, often at the worst possible moment during overtaking maneuvers. No warning, no gradual deterioration, just sudden, complete disengagement. Now, equally dangerous was the engine's cam chain tensioner, which routinely failed without warning. And when it did, the cam timing shifted instantly, causing valves to strike pistons with catastrophic internal damage. The triple Mikuni carburetors featured complex linkages that frequently went out of synchronization, causing dangerous surging and hesitation. Now, most alarming was the shaft drive system, innovative for Yamaha, but deeply flawed in execution. The drive shaft's geometry created a rising rate suspension effect during acceleration, literally lifting the rear of the motorcycle during hard acceleration and dropping it during deceleration, making cornering unpredictable precisely when stability was most needed. Early models suffered from crankshaft bearing failures, often with no warning signs. Main bearings would suddenly spin in their housings, locking the engine instantly, potentially at highway speeds. Well, if you ask me, that's some pretty scary stuff. But thankfully, that's it for today, guys. Think your bike belongs on this list? Drop us a comment, and like if you've battled one of these beasts. And don't forget to subscribe with notifications on for more motorcycle truth bombs nobody's talking about.